Okay, the wheels on the bus go round and round. We're at 20 now. Again, when I said the wheels on the bus go round and round, that means we're moving forward. We're going to move forward, one section at a time until we get to the last section, 139. Maybe I'll go through the appendices. I'm not sure about that at this point. For a lot of people, it's exhausting. You can always take a break and come back whenever you want. And again, we're looking forward to moving forward. Actually, we're looking forward to. So let me just point out, we're at the section 20 now. And really, the whole section is designed to get you to do the exercise 20. There's going to be contents. There's going to be examples, which I will go through with you. And there'll be exercises that you need to do on your own. My name is Ron Bannon. If for whatever reason you need to reach out to me, I suggest you do that by email. My email address is Bannon. That's B, the @ symbol, NNON.US. And again, hopefully I don't get overwhelmed with emails, which is unlikely. Not many people are too interested in this area. They find it too difficult, I think. So the bottom line is just going to kind of scroll through. All right, not going to read it to you, though. Oh, by the way, let me just point out again, I know I say this so often to you, the actual PDFs are only being distributed now to the Prison Mathematics project participants only. Again, in the future, this will be published. My expectation is going to be around 3,000 pages long when it's published. And then I'll probably publish it as a PDF, all right? Not as a paperback book or something, or hardcover. I mean, a huge book. So this one over here is, again, this is something that you would not see in algebra anymore. And it's tough. I'm not saying it's going to be easy for you, but they're talking about symmetrical expressions and factoring a symmetrical expression. So someone says, why do they do this to me? Why do they come in? I think their really hope here is that they're really trying to point out that there are patterns. Right? Now, certainly there are patterns when they point them out. In the real world, though, no one's pointing out the patterns to you. Right? You'd have to be observant and see the patterns. And the world is full of patterns, and patterns that people predict on. And I will say this, successful people do observe the world. Not that people are pointing out what the patterns are. They observe the world, and they tend to recognize patterns pretty quickly, and they exploit those patterns. Whether it's for a business opportunity, whether it's for investing, whatever, they see patterns. Patterns can be tough, though. I'm not saying they're going to be easy. All right? So the deal about this one over here, I want to point out, we'll go through the examples. As we go through the examples, you might find this to be incredibly difficult to follow. And I'm not going to say it's going to be easy. I'd say that if we were teaching this nowadays, I think we'd give up on it. I really do. All right? So, looking at this one over here, again, I may approach it differently than Wells does, but that's okay. I mean, Wells does what he likes. I do what I like. All right? So I'm looking at this thing over here, and I'll be perfectly honest with you. If someone asked me to factor this thing, I'd say, gee, that looks crazy to me. I don't know if I could do that. But I got to be honest with you, they're not asking you to do that unless it's doable. All right? So what I'm going to say is, looking at it, there is some sense of symmetry to this. All right? In other words, I can say it's symmetrical with respect to A, B, and C. And that might be really tough to write down and show you that. But again, if you interchange those things, like A, B, and C, you get the same expression over and over again. All right? And, someone says, oh, it's third degree. Why is that? Well, I'm looking at squares, and if you look at the A's and stuff, you're looking at the term-wise anyway. I'll point that out to you. By this way, let me put a pen over here. That, you'd have A, B squared in that. And that's degree 3, by the way, because the degree there is 1, 2. That's a 3. Let me get my eraser out. I'm going to degree 3. All right? So the next thing is kind of looking around, and I'm wondering, could there be a simple root to the problem? All right? So, it says, suppose A is a factor of the problem. And I certainly don't want to go through looking at the factorization, but I'm saying suppose it is. So I'm kind of stabbing at it at this point. So if A is the root of the problem, I say, hey, set A to be 0. Let me write that down for you. Now, could you do that for B? Of course you could. I'm just wondering, could I do that just for the root A? I'm saying the root A. Well, what would I do? Well, if I looked at that, I want to point out, it really doesn't look that bad to me. And I'll tell you why. If A is 0, what would you get for the first term? And by the way, I'm talking about terms. This term, this term, this term, this term, this term, and this term. I'm going to see if it's true. All right, so what do you mean it's true? I'm going to see if it's true. If a is 0, what would I get for the first term? 0. What would I get for the second term if a is 0? I would get bc squared. G, what would I get for the next term? If a is 0, I would get cb squared. All right? I'm going to write that down as b squared c. Now, if a is 0, the next term would be 0. The next term, if a is 0, what would I get? I would get b squared c. What's the next term going to be? Well, I'm going to write it down. It's going to be minus bc squared. Is that equal to 0? Let me take a look. All right, so I got the bc squared. Gee, they disappeared, didn't they? And these disappear. It is 0, so a is a root. Right, this is a success story, all right? Now, what it goes on to say, and certainly I'll go through this with you, it goes on to say that now we know a is a factor. By symmetry, we now know that b and c are factors. Right, we know they're factors, by the way. We know a is a factor, we know b is a factor, and we know c is a factor. We know they're factors, all right? Now, certainly, if we know they're factors of the problem, right, we know that the a is 0, b is 0, c is 0. We know that, all right? So my claim over here, if we knew that, the bottom line is it's nice to know that. And again, reading is going to be a really important thing for you to know. So let me repeat this over here. Once we show, and it's symmetric, once we show that this is a root, we now know that b and c are also roots. What does it mean? B equals 0, c equals 0 will also produce a 0 in the problem. All right? Now we know that a is a factor. By symmetry, we know that b and c are also factors. So now we know our expression has a factor of a form some multiple of a, b, c, where k is some constant. I just don't know what it is. All right? I have no idea what it is. So what I did was I write this down over here. Again, I know it has some multiple of an a, b, c in it. All right? So let me make sure you know what we're doing over here. I want to be really careful with it. I'm just recopying this over here. All right, make sure you know that. Term by term. 1, 2, 3, 4, 5, 6 terms. And then I'm putting this over here. Okay? Now someone says, what are you going to do with that k? I'm trying to figure out what the k is. So to figure out the k, what I got to do is I got to pick easy a, b, and c to do it. I got to figure out an easy a, b, and c to do it. I have to. All right? Now, I realize someone says, what are easy a, b's, and c's for you? Well, for me, it would be if a, b, and c are equal to a number I can handle. Now, someone says, let's choose 0. No doubt about it, it's easy. Unfortunately, if I did that, I want to point this out to you. This would disappear, and I'd have no idea what k is, and I don't want that to happen. So what I'm going to do is look at, is there another a, b, and c I could use that's easy? And I'm going to say, yeah. The one I'm going to choose is, I'm going to choose this one where a, b, and c are 1. So what I want to do is I want to start writing it down for you, all right? So I'm going to write down, I think it's easy to do, and I'm going to do every single term now. And someone says, what do you mean every single term? I'm going to say a equals b equals c equals 1. Let's write this down. What do you get over here? You get 4. Let me tell you what it is. If a is 1, b is 1, and c is 1, well, b plus c would be 2, and 2 squared is 4, and 4 times 1 is 4. Let's go to the next term. What would I get over there? I would get 4. Why is that? I'm saying a, b, and c are 1. What do I get for the next term? Should be easy. I get 4 again. Next term, what do I get? Well, a little more complicated, isn't it? Not really. I get 1 times 2, which is 2. Again, we're doing the terms one at a time. You could choose different numbers if you don't like 1, 1, 1. Let me do this one. What do I get? Minus 2. Let me do this one. What do I get? Minus 2. Now, what do I get on the other side? I get k times ABC. Well, if A, B, and C are 1, I just get k. So right now, I think I know what k is. And how do I do that? Just add all the stuff together. All you have to do. You'll find out what k is. What do you get? You're going to get 6. It's a pretty easy addition problem. All right? So someone says, well, big deal, you got the 6. So here's the deal. I'm just writing this over again. I'm saying, gee, I got a 6 out of this guy over here. Get the idea? All right. someone goes, wonder what you're going to do now. And what I'm claiming over here, this might seem outrageous to you, I am claiming that this thing here factors to this thing over here. All right? So someone's going to say, I wonder if that's true. You could expand this guy. And not that I want to do it for you, but you could. Let me write that down for you. What would you get? A, and it's going to be a nightmare for me, b squared plus 2bc plus c squared. Let me put the next one down. B, c squared plus 2ac. It's a nightmare for me. I'll be honest with you. Plus a squared. I did this one, did this one. Let me do the next one. Plus c a squared plus 2ab plus b squared. I just did that. Now let me do the last three. These over here. I know they're all subtractions. I'll write that down for you. And what would you get? Minus a squared b minus a squared c minus b squared c minus ab squared. It's worked though. I know that. I'm doing this one and that one. Let's do the last one. And I hate doing it, I'll be honest with you. That's minus ac squared minus bc squared. Now someone says, why are you doing that? I am really hoping in the end of it, it's 6abc as we expect it to be. All right? So let's keep going through it. Yes, I know it's work. I'm expecting that this thing in the end is going to turn out to be 6abc. I'm not there yet though. Let's write this down now. So I'm going to do this over here. And I'm going to put that top line down for you. What do you get? A, b squared plus 2abc plus ac. Whoops, I'm sorry, I misspoke. I'm daydreaming. I do it all the time. Let's see, ab squared, abc, and then ac squared. Sorry about that. Plus bc squared plus 2abc plus a squared b plus a squared c. It's even hard writing down. Plus 2abc. I like alphabetical order, by the way. Plus b squared c. And now I'm going to put this thing down below it, this minus thing, and I'll write it down for you carefully. And the first thing I'm seeing is minus a squared b. And then minus a squared c. And then minus b squared c. I'm just doing these guys over here, by the way. Let's see, I said minus b squared c, right? And then minus ab squared. I like to line things up, by the way. Minus ac squared. Minus bc squared. And let's see what happens. Disappears, 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 disappears. And we left off with two of these, two of the same thing. Wow, there's 6 of them. Exactly as we expected. All right. We're not expecting to do that, by the way. We're just not expecting it. Okay, here's another symmetric one. And it says the expression is symmetric with respect to x, y, and z. So bottom line is, I'll say x equals 0 as the root of it. All right? So someone says, could you show that's true? Right? I could. You plug it in, and I'll go through that with you. This would become 0, first term. Second term, if x is 0, what would you get? You would get y squared z. Again, we're checking to show that this is a root. In other words, it's going to be 0. What's the next one going to be? Let me see. Simply studying show that x is a factor. Oh, not a factor. I'm sorry. It's not a factor. It's not a factor. Let's keep going. Plus, what did I do over there? I just did this one and that one. I'm going to the next one, and x is 0, right? So what would you get? You would get yz squared. And if x is 0, you get nothing last term. Well, the bottom line is, looking at it, I'm not getting 0, right? Unless, of course, these things are simultaneously 0. But I'm not getting a 0, right? I'm not a root. So they asked me to show that, and I did that. Let me kind of erase this over here. I'm kind of done with that part. Yeah, I know it's tough. we showed it's not a root, all right? And that is, we just did that. We came up with this thing over here, by the way, all right? Now, moving on, let's try something different. And what I'm going to say is, let's try something different. And what am I going to try? I don't know, x plus y is a factor, all right? Let's see what happens over there. So someone says, when you say x plus y is a factor, let me write this down. I'm going to say x plus y is a factor. What does that mean? X plus y is a root, which means x equals minus y. Okay, let's go back over here. And what I'd like to do is just plug it in, see what happens. All right, so I'm going to make that next jump up and wonder what happens over here. So let me get my eraser, because I know it's not erased fully. So I'm going to say x equals minus y, right? So what do you get over here? You would get y squared, y plus z, plus y squared, z minus y, because x is minus y, right? Plus, what do you get over here? Z squared, well, x plus y is 0, right? Plus 3, what would you get there? If x is minus y, I'll write that down for you, you'd get yz, right? Let's see if we get what we get over here. And again, I know I'm not saying it's easy to do. I'm just saying I'm stabbing around. I'm looking for something. You would get y cubed. I'll write this up here. Plus y squared z. Let's keep going. Next one's going to be plus y squared z. And then minus y cubed. That next term is 0. I'm just going term by term. And then when you get minus 3 y squared z. All right, let's see what we got over here. And you get, this disappears. I hope you can agree with that. And unfortunately, when I do that, what's happening over here? I'm getting 2 of these things. So it's not going to be 0. It's going to be minus y squared z. So this is not a 0. So this is not a 0. Not a 0. Okay? So over here, I want to point out, I'm going to say, let's see if this is the factor. And it turns out not to be a factor. It's not equal to 0. So I got to move on. I have to move on. I just say, I don't know. Let's move on to the next one. Let me get my eraser out. And someone says, you're unsuccessful so far in 2 attempts. It can happen. Let me get my eraser out. Give me 1 second. Whoops. I think I went way too fast there. Sorry about that. I lost track of where I was. Let me do this over here. I think I was in section 20, right? Let me do that. I'll get to section 20. Sorry about that. I pushed the wrong button. Also, I'm in some other paradise or something, right? Section 20. I think we're over here. Not an easy section, by the way. All right, problem number 2. Let me get my eraser out. I apologize for doing that. I'm going to outline what we've done so far and where we need to go. All right? So let me point out what we've done so far. Unsuccessful. All right? I couldn't show x as a root. Couldn't do it. I couldn't show x plus y is I'm sorry, I didn't mean to say root. X equals 0 is a root. Couldn't do that. I couldn't show this as a root either. And what does that mean? I couldn't show x as a factor, or y as a factor, or z as a factor. I couldn't show x plus y as a factor. Couldn't do that. What am I going to do? I'll go with the next one. Someone says, what's the next one? Well, it is more complicated. I know that. They're getting more complicated. What I'm going to do is I'm going to move on to this one over here. I'm going to see if that's a factor of the problem. And that is, I'm going to make a substitution, and someone says, what's it going to make? Let me write out what I mean by that. If I say that this is a factor, I'm saying that x plus y plus z is equal to 0. So what I want to do is I want to maybe solve for one of those letters. I'm going to solve for x. And this might be another dead end. And what's x going to be? Well, it's going to be minus y minus z. Now, there is some students who say, oh, you're stabbing in the dark. I am. I'm stabbing in the dark now. All right, let's do this, and I'll write it down for you. Now, but when I write this down, I want to point out x can also be written down as minus y plus z. Same thing. So I'm going to plug it in. I'm going to see what happens. What's x? Well, it's minus y plus z. What do you mean you get square of that? You would get y plus z squared times y plus z. That's this thing right over here. Let's do the next one. What do you get? You get y squared. Right, I'm not saying it's easy, by the way. And z plus x, right? Well, that would be z minus y minus z. What would you get? Again, let me make sure you know what we're talking about. We're talking about this thing over here. Z plus x is z minus y minus z, so it's just a minus y. Let's keep moving. I just did this one. Let me do the next one. That's z squared. All right. Now, what's x plus y? Right, I got to think about it. Well, x is going to be minus y minus z, so I just get minus z. All right, here comes a tough one. 3. And what do you get over there? What's x? It's minus y minus z. I'll write that down for you. Times y times z. What am I hoping? I'm hoping that's 0. I really am. Because I'm exhausted. Let's go for it. See if it is. All right? Let me get my eraser out. I'm going to erase all this highlighting stuff. They were dead ends. Yep, a lot of dead ends in life. I'm going to erase this over here. And again, we're testing out. Maybe I should point that out to you. Again, we're testing out to see that's a factor. And if it is, it would be nice to know. It really would. So let's go through it. Let's see what happens. And it's work. There's no doubt about it. So I'm gonna do easy things first. I'm gonna do this guy over here. I think it's easy. What do you get over there? I'll write it down for you. That would be minus y cubed. I also believe this is easy to do. What's that going to be? Minus z cubed. I'm also going to do this guy over here. I think it's easy. And say, why aren't you doing the other one? I'll do the other one later. All right, what do you get there? Let me write that out for you. It's 3yz times minus y minus z. So what do you get over there? You would get minus 3y squared z. Then you would get minus 3yz squared. That's not so bad, by the way. Let me just get my eraser out. I want to just put a lot of work down. I don't need it. I got to do this thing. And I'll point out, for a lot of students, they can't remember. And don't worry about it. I can't remember a lot of things, too. But this is actually a perfect cube. And I think I know that. And what do I mean by that? I'll write this on the side for you. Whoops, I didn't mean to do that. I'm going to say this is y plus z cubed. And we've done this before. Let me write this down for you. Y cubed plus 3y squared z plus 3yz squared plus z cubed. Let's write this down now. All right? So what do you get over here? Y cubed plus 3y squared z plus 3yz squared plus z cubed. Now, I think you probably know what I'm hoping for. Hoping for a 0. That's a lot of work. Let's take a look at this. Get my red pen out. And I'm going to say that disappeared. That's good news. I forgot. I miscopied. I just noticed it. This disappears. This disappears. Let me get my red pen out again. This disappears. This disappears. This disappears. It's 0. And this is good news for me. Now, I'll tell you why. I now know this is a factor of the problem. I know it's a factor. It's a success story. I got a 0. That's success. So what I'm going to do, I'm going to use that success to actually factor the problem. All right? Now, by the way, someone's going to say, how are you going to do that? Well, I'm going to write down, make sure I'm writing down the right problem over here. Yep. This is the original problem. I wrote this down. Whoops, I'm sorry. I jumped a step ahead. I don't want to do that. That's crazy. I don't want to do that. Not there yet. I'm here. So I wrote the original problem down, and all I said is it must now have a factor of x in it. But I hope you realize you're looking at that, it's got to have more than that in it, right? Someone says, what do you mean more than that? Well, if you look at this thing, there would be some unknown factor over here. And why is that? There's no way it equals some constant multiple of x plus y plus z, because none of the terms disappear. All right? So what I'm going to do over here is I'm going to plug in. And someone says, what would you plug in? Well, I don't want to plug in x equals y equals z. It's symmetric, by the way. Equals 0. I'm going to use a number that I find to be easy to deal with. So I'm going to say x equals y equals z equals 1. And I'm trying to figure out if I can do it. So let's see if we can do that. And this is a plug-in now. I'll put out what I'm plugging in. I'm plugging in 1. So what would you get? I'm going to do one term at a time. You would get 1 times 2, which is 2. The second term, what would you get? 1 times 2, which is 2. Third term, what would you get? 1 times 2, which is 2. What do you get for the next term? Again, if x equals y equals z, you'd get 3. Now what do you get? K times x plus y plus z is 3. And then I got something over here. I don't know what it is. Or I have no idea what that is. Let's take a look at it. Right? So we'll take a look at that. And let's take a look. What do you get? 2 plus 2 plus 2 plus 3. That's 2, 4, 6, 9. I'll write this over here. You get the idea? All right. Whatever this thing is over here, it must be the number, right? It must be some number. Whatever it is, must be some number, such as a product equals 9. Now, by the way, someone can say, I know there's something here. I just don't know what it is. Here's the deal. Right, let's go through that and make sure you understand this over here. It's got to have some factors in it that have letters in it. And why is that? If you expand this guy over here, and expand this guy over here, and expand this guy over here, and expand this guy over here, you're going to be getting terms. All right? So I'm going to say over here, that unknown factor is not so bad to determine. Right? What's going to have to contain? This guy over here. It must contain that. So what I want to do is I want to go back over that and say that I think I can think a little bit forward now, because this kind of goaded me on saying there's something over there. Erase this over here. And let me put that factor down now for you. And what's the factor we're expecting over there? Well, I'll write it down for you. I'm expecting to see this guy over here. What would I get over there? 1 plus 1 plus 1. What do you get over there? Well, again, what are you getting? 2 plus 2 plus 2, which is 6, 9. This is going to be k. 3 times 3 is 9. So what's k? K is 1. So I think I'm ready to write the factorization down now. What's the factorization? Well, we know it has that factor. We've already shown that to be true. This is the missing factor, more difficult. I'm not saying it's not easy for you. And the k is actually the number 1. K is 1. We just went through that. What's the factorization? This is the factorization of that. That's a lot of work. I know that. What we'd recommend, I really do mean that, is to multiply it out and see if you get this thing over here. What I mean by that, you multiply about both sides and see if both sides give you the same thing. That's how we generally do the factorization. All right, let me do the next one. Sorry about that. And these are tough, long problems. The last one's 3, right? It's a tough problem. There's no doubt about it. All right? So, I'm looking at this thing, and my gut feeling about this is what we've been doing before, it hasn't been easy. It's been tough. So what I'm going to claim over here is just kind of looking at the problem. Maybe I should start thinking about maybe a different technique. All right? So what I want to do is I want to multiply it out. This could destroy any pattern that's in the problem. All right? But I'm going to multiply it through. Right? I'm not going to say it's going to work for me. I'm just going to look at it. And what would you get? You would get a squared b, this sometimes works, sometimes doesn't, minus ab squared. That's this first guy, done. Let's do the next one. What's the next one going to be? B squared c minus bc squared. That's this guy, done. Then what do I get over here? plus, what would you get? C squared, or AC squared. And then you would get minus, what would that give you? That would give you A squared C, right? All right, let me point out where this is in your notes. This is written down over here for a reason, by the way. We want to make sure that what we said is correct. A squared minus AB squared, B squared C, minus BC squared, AC squared, minus, I'm sorry, AC squared, and then minus A squared C. All right? So the other thing about this one is that if you're looking at it, yeah, it's like a lot of symmetry in the problem. But again, sometimes you look at it and say, I don't know if that's really what I'm looking for. And you really are looking for symmetry in the problem. What I'm going to do is I'm going to say, kind of looking at that, you know, I'm going to say that, again, looking at it, I'm going to say there's a sense of cyclosymmetric expression in A, right? And I'm going to look at it. I'm going to say, let's substitute A equals 0 into the problem. And I hope you, by doing that, you're going to notice that you would not get a 0, all right? So you'd get a 0 here, you get a 0 here, you get a 0 here, you get a 0 here, but you're left off with the B squared C minus BC squared. You're not getting a 0, all right? So I'm going to say, are there other possibilities in the problem for roots of it? And we're looking for simple things. We're not looking for difficult ones. Let me kind of erase this over here. Again, we're looking for nice, simple patterns. Let's try another one. I'm going to try over here. You know, what about A equals B? And what does that mean? If A equals B, right? If A equals B, what does it mean? A factor would be A minus B. Okay? Let's see if we can do that. Let's see what happens. If A equals B, what would you get? If A equals B, you get B cubed minus B cubed plus, let's be careful with this, all right? So A equals B, right? Let's do the next one. And I'll look at those two little terms over there. I'm just looking for the A's in a problem. That would be BC squared, A equals B, right? Minus B squared C. And what do you get over here? B squared C minus BC squared. Well, these things, I'll point out to you, they disappear. And what happens over here? Well, this cancels this, and this cancels this. So right now I know that this thing is a factor of the problem. I know that, all right? Now here's the problem. All right, let me start to erase that. Where's my eraser? Right over here. I kind of just checked that out, right? There's tremendous symmetry here, though. So I'm going to say if A minus B is a factor, A minus C would be a factor. I'll write that down for you. Now, I'm not going to go through the verification of that, but you could. And I'm going to say B minus C would be a factor. Now, certainly you're going to make mistakes. Let's write this down. And as I write things down, I'm going to write it down. I'm going to write this down. AB, A minus B, plus BC, B minus C, plus CA, C minus A. Now, we've already shown that A minus B is a factor. I'm looking at the symmetry, and the symmetry is leading me to believe that A minus C would be a factor, and B minus C would be a factor. So let me write this down. I'm going to see if this kind of works out, if there's any missing factors in the problem. So I'm going to say A minus B, A minus C, B minus C. And what I get, you know, what I'm expecting to get, which is, you know, A squareds and a B, yeah, I'd get it. I'd get all these things over here. I'd get them all. I just don't know what the K is. So I need to find something. By the way, you might say, let me pick the A equals B equals C equals one thing. That's a problem, though, and I'll tell you why. If you did that, this side over here would become 0, and you'd have no idea what the K is. None whatsoever. By the way, this side would also become 0. You'd have no idea what the K is. So we need to pick another value of the A, B, and the C, and I'm going to write that down for you. And you can pick any numbers you like. Don't think it's like these numbers that I'm picking, the only numbers you can pick. You want to pick numbers that are easy to evaluate. So what I'm going to do is I'm going to pick something. And I'm going to pick something that, you pick your own numbers. You can even pick your phone number if you like. I'm going to say A equals 2. And I'm going to say B equals 1. And again, you can pick different numbers, and C equals 0. I find those to be pretty easy numbers. All right? Let's go through it, and I'm going to go through it one thing at a time. I want to do the first term. A is 2 is B is 1. Right? So what do you get? 2 times 1 is 2, and 2 minus 1 is 1, so I get 2. I'll write that down for you. Plus. Well, this one's nice, because this disappears. C is 0. And this is nice. C is 0. Couldn't get better on that one. All right? So I'm going to say 0 plus 0. I got a K. I don't know what it is yet. Let's figure it out. And then the problem comes, figuring out. Could you figure it out? Let's take a look. A minus B. And again, I want to remind you, this is what we're looking at. What's A minus B? It's 1. What's A minus C? 2. What's B minus C? Is 1. I think I'm ready. This is 2. And what do you get over here? 2K. What's K? K is 1. So I think I got the factorization. Let me erase. And I'm pretty sure I got the K to be 1. I'm not going to write that down because 1 is a coefficient of that. I'm going to say that's my factorization. It's work, though. I'm not kidding. It's a lot of work. So my question is, did I get it right? And I'm going to point out over here, answers right over here. It's tough, though. I'm not saying this is easy business. It's not easy business. All right. What's the problem about this over here? Yeah, you might see the way I do it or the way Well does it. Talk about symmetry and roots and factors. There's a lot of confusing things. All right. What are we basically doing? We're looking for easy things, and then we're moving forward to things that might be far more complicated. All right. But we went through a couple different examples, 3 different examples, and certainly Wells does it. Might look different the way I'm doing it, but we're getting the factorization. We're getting equivalent factorizations. Probably the single best way to factor a problem is to look at it and start trying something. I'm not saying you can't do it. For example, you might want to look at this instead, all that business I went through, and simply say, you know what, maybe if I grouped it differently, I'll get a factorization of that. And you know what, that's not a bad idea, to group things differently to see if you get a factorization of it. There's a variety of ways of doing things. Do not think what I just did is the best way of doing it. The best way of doing it is to play around with it. And if they say factor, if they say it, I bet you can factor it. I really do. You can play around with it. Let me repeat that. If they say factor, you know what? I bet you can factor that problem over there. I bet you can do that through the techniques that maybe I go through. Might be difficult for you, but you can do it. All right? Again, if they say factor, there's a really good chance you can factor these problems over here. It's not easy, though. Factoring can be really brutally difficult. All right? As you go through the exercises, though, I got to be honest with you, these exercises really aren't so bad. What do? I would say try it. Any technique you want, by the way. You can be looking for roots. You could be doing long divisions. You could just be doing groupings. Whatever works for you. I really mean that. Whatever works for you. I go through it, though. I write this up for you as well. Right? Same thing this one over here. They want you to factor it. Any technique you want to do. You want to look for roots, factors, long divisions, whatever's working out for you. It does factor, though. It factors out nicely. Same thing this one over here. Factor it. Look for something. What are you going to do? Look for roots, maybe long divisions, rearranging things. It's going to factor. There's no doubt about that. I'm not going to say it's going to be easy, but it's going to be factorable. Same thing with this over here. It's factorable. They're factorable. That's really what they're saying to you. It's factorable. Yeah, it's a lot of work. No, none of these problems are going to be easy for you to do. It isn't like you stare at them. This one might be easy to do, but it isn't like you stare at something and say, gee, I got that factored. It's going to be work. This one's a little bit easier to look at, by the way. It's factorable, all right? They're using symmetry and all kinds of things. Related Sage code, what is that? It's a computer algebra system. Sage is free. It's available here at this website. You can download it as an application or use the interactive web-based thing. That's what we kind of did in the first few videos we talked about it. What are we saying? Get familiar with it. And I got to be honest with you, These problems are so simple to do on a computer algebra system, it's ridiculous. Someone says, why is that? The people coding know about this. They have studied this form of algebra. They could not have done it otherwise. They must have studied this form of algebra to know that. And the reason for that is, in order for them to code something, they must know what those techniques that we've done by hand. They must know it. Just like the code arithmetic in a calculator, you would need to know how to do arithmetic. But boy, our calculator's good at that. All right? So anyway, make sure you look through that if you're interested. Again, if you need to reach out to me, my email address is Bannon. That's B as in boy, @nnon.us. Thank you so much for paying attention. Hope to see you soon.